Hello and welcome. You are going to look at an algebra review with example problems. This is really just a crash course in what you might not have remembered in algebra from the past. Alright, and we're going to jump off pretty strong here. How many solutions does the quadratic 2y squared plus 2 minus 4y equals 0 have? This one's actually kind of an interesting case because you're using y instead of x. What you're treating y as, though, as an independent variable. So for the sake of this problem, I'm going to change it to x. I know we're a lot more familiar with that. So let's go ahead and do that. Plus 2 minus 4x equals 0. Okay, when it's asking for solutions, in this very case, it's asking for how many times does it cross the x-axis? Or furthermore, when you solve for x, how many different solutions did you get? Okay. Probably a lot of ways to do this. I'm going to take a look at a couple of them with you and for you. First things first, this is a quadratic equation. Standard form for a quadratic equation looks as follows. Y equals ax squared plus bx plus c. Or if you substitute 0 for y, you get ax squared plus bx plus c equals 0. Now, there are multiple ways to solve this kind of thing. There are namely three to consider. One is solving by factoring, meaning if this statement is factorable, we would go ahead and do that, and we would use what's called the zero product property. I'll go ahead and do that one. I think this one is factorable. A second way is solving by completing the square. Okay. Another way, I'll go ahead and do this problem with you. And a third way is solving by using quadratic formula. So this number one's actually going to take a while. I don't anticipate doing this for every single problem, but for this one, I figure I might as well start off strong for you, especially because if I have future problems like it, then I might not have to redo them that way. I'll probably just choose the best way. Alright, this is ax squared plus bx plus c equals 0. Our linear term is written in the wrong spot here. Okay. Now actually, and to be even further whatever with this, the quadratic formula includes something called the discriminant, which is actually the one way we can truly solve for it without even actually solving for your variable. So I'm going to make sure to keep that in mind as well. So there are kind of four ways I'm going to do this thing here. That last one's actually probably the quickest. So I can solve this by factoring. Before I actually do any quadratic factoring, which I can do right now, I'd rather instead find a greatest common factor and take that out. The reason for that is because I get smaller numbers. I don't have to deal with an a value that's not 1. If you can factor a 2 out, you'll be left with this. Okay? So from there, I can divide both sides by 2. The benefit of just not factoring this problem but solving by factoring is this 2 is unnecessary. And 0 divided by 2 is 0. When we use the zero product property, I'm actually looking at it right now. If I multiply 2 with a number and I get 0, then this number must be 0. 2 can't be 0, so I'm ignoring it. This quantity here must be 0. So the question is, what values kind of get me this here? A lot of ways I can look at this to cater toward those who've been kind of weak with algebra recently. The way to factor is to think about the opposite effect. There's a number that there are two numbers that combine to become negative 2x. Those same two numbers in this case, because this number is a 1, multiply to become 1 as well. If I'm looking at 1x squared right here, and if I'm looking at 1 right here, I have two numbers here that are adding to become negative 2x. The question is, what are they? Well, there's a little trick that says, let me actually write this as a 1 here. There's a trick that says if you multiply these two, the coefficient here and the constant here, that product will be the same as this product right here. Not that they're necessarily the same numbers. They could be, but not necessarily. So in your diamond, you say, okay, 1 times 1 is 1. So this number times this number is also 1. Now the two numbers that add together, once again, add to become negative 2. So you're looking for two numbers that multiply to become 1, add to become negative 2. Those numbers are negative 1 and negative 1. Now keep in mind, it's not just negative 2, it's negative 2x. So this is negative 1x. This is negative 1x right here. Not often do you actually see a generic rectangle with all 1s and negative 1s as your coefficients. So the opposite effect is as such. The reason why the x squared was in the bottom left and the top right had the constant right here is because you want to multiply x in two different spots here, so it's not just x squared and 1, because x you need to multiply with something to become x, where nothing multiplies out here with an x to give you 1 because there's no x here. So these two have x's in them, and actually this is one of the easier kinds of generic rectangle problems. Only 1 times 1 can give you 1. Keep in mind we're looking for integer factors only. 1 times negative 1 gives you negative 1. 1x times negative 1. There you go. 1x times negative 1 right here. So this becomes x minus 1 times x minus 1. You can see it's basically what we're doing is this is the area of something, and these are the dimensions, your base and your height. So if I multiply base with height, I end up getting that right there. Whoops. Now that is factored to this, and now we actually have a proper setup where we can solve for x. The problem with what we had before is that you couldn't isolate one x on its own. And in fact, let me do this actually two different ways from here. This is going to be a long problem. I'm already acknowledging this. First of all, let's do it this way, zero products property. If a times b equals 0, then either a must equal 0 or b must equal 0. You cannot ever multiply two non-zero numbers and get a product of 0. So one of these must be 0. Now the thing is, these are both the exact same thing. So this just says x minus 1 equals 0, therefore x equals 1. This is the value for x that you can substitute into this expression right here, into either quantity, and you'll get 0 out. Likewise, that would also work right here. 1 squared is 1, minus 2 is negative 1, plus 1 is 0. And that works out. That also works for the original thing up here, or even all the way up here. Remember, this was originally a y. Let's write y equals 1. Remember, I didn't answer the question yet. But if I substitute 1 for y, 1 squared is 1 times 2 is 2, plus 2 is 4, minus 4 times 1 is negative 4. 4 minus 4 is 0. That still works. The question is, how many solutions did this thing have? The answer is one solution. It didn't have multiple solutions here. You can't say y equals 1 or y equals 1. It's just y equals 1. It has what is called a multiplicity of 2, but there's only one proper solution. Now the second way of going about this here is that this is x minus 1 quantity squared, and that equals 0. The same thing times itself equals that value squared. So what I could do from here, which is actually what I'm going to do when I solve by completing the square, the exact same thing, I can now take the square root of both sides, because this is the only term in this quantity here. The square root of a squared value is just the value itself, and the square root of 0 is 0, and you get the exact same thing, or in this case, y. So that's solving by factoring. That had a little hint in what we're going to do in completing the square at the end. Let's do it by completing the square next. Okay, in terms of completing the square, the entire idea is that you get this into a form such as this, where you have a perfect square on this side, and then another value on this side. It can't be negative. If it is negative, you take the square root. There are no real solutions. But this allows you to take the square root of this. I cannot take the square root at this step right here. I can't just say, oh, let's just take the square root of that. Yeah, that'll be fine. And I know that kind of sounds ridiculous, but people do that. You know, people kind of don't truly know how either the algebra works or just assume things can happen just because. You have to keep equations balanced, and that's actually one big component of completing the square that I'm about to do. Okay, first things first, it's very difficult to complete the square. It's a lot harder when you have a 2 as a coefficient, as a quadratic coefficient. So actually getting to this step is ideal for me. You know what, completing the square here is not going to be, this already is a perfect square. I guess I can't do completing the square in this one. You know what, in fact, I'll still do it, just it'll be kind of stupid. It'll be like, well, why did you do that? Well, just to show you how completing the square works. So I'm going to rewrite this. The only thing I'm going to do is I'm going to subtract this 1 over to the other side. The main idea behind completing the square is you make the assumption that the value that you have as your constant term is not the ideal value that you want for your equation, for your trinomial. In this case it is. This already is a perfect square trinomial. And we're going to get a 1 back. But let's say you didn't know, or let's say it was just set up like this and they said you must complete the square. Alright, so as you see, I have 2 underscores right here. I'm going to fill in some number. I'm going to fill in the same number on both sides, and it's going to be added on both sides, because if I add a 20 over here, I have to add a 20 over here. That's balance of equations. Just like I subtracted 1, I subtracted 1. Take a look over there. That's how this came to be. So you have to keep equations balanced. To complete the square, not to get too deep into it, you're going to take this number, you're going to divide it by 2. That number is negative 1. And then you're going to square that. SQ it. Negative 1 quantity squared is 1. This is the value that completes the square. It basically makes a perfect square trinomial. It makes the base and the height the exact same measurements like this. Now this ended up being the exact same thing. I add 1 here, I add 1 here. Awesome. So this actually just becomes, if this number was 2b, this number is b. It becomes x plus b, quantity squared. The b is negative 1, so it becomes that. Negative 1 plus 1 is 0, and we're right back to where we were over here. Obviously, we get to the same stuff. Take the square root of both sides. But the point of this was to make this a perfect square trinomial, so you could factor into this form. This is the form that allows you to take the square root of both sides. Maybe we'll run into another equation where we can end up doing that. Okay, the third way, and there's actually a 3b in doing this, the third way is solving using the quadratic formula. Okay, and you can sing it, you can do whatever. At some point, you just know it. That'll be great if you did. I use Jingle Bells, the tune of Jingle Bells. Minus b plus or minus the square root, stuff like that. Okay, there it is. If you substituted your a, b, and c values, now keep in mind you can either use these a, b, and c values here, or you can use these a, b, and c values right here. When in doubt, always try and get the smallest ones that you possibly can. That's good. You just deal with smaller numbers. To kind of prove that this all works, though, I'm going to use these numbers here. Make sure you still get the same x, or in this case, y values truly. Remember, this was a y explanation. A is 2, b is negative 4, c is 2. So a is 2, b is negative 4. Okay, one way to go about this is just plug these in until you get a solution. Now, keep in mind, I'm already stressing, this is not only not the ideal way to do this kind of problem, this is also not the ideal way to do the quadratic formula. I'll explain why in a bit. Actually, you'll kind of see it. That's a negative 4. Minus 4ac all over 2a. Okay? Oh, 2 times 2. The opposite of negative 4 is positive 4. Square root, negative 4 squared is 16. 4 times 2 is 8, times 2 is 16. And you're left with that right there. Square root of 0 is 0. So I'm going to separate this now into two equations, just like I did here. Well, I didn't technically, because this is the same thing twice. This actually is the same thing twice here, as you can see. So x equals 4 over 4, which is 1. In this case, it really was a y equals thing, but we still get the same answer. Okay. It might only save you a step, but the majority of the work that I had to do was actually within here. I had to calculate all this stuff while rewriting everything else. I know I had to do 2 times 2 and the opposite of negative 4. Those ended up not being too bad. Most of the work gets done in here. This stuff in here, b squared minus 4ac, this is called the discriminant. B squared minus 4ac is called the discriminant. What the discriminant does, by the way, this still shows there's only one solution. What the discriminant does is it determines how many solutions there will be in your quadratic equation. B squared minus 4ac, I want you to look at what I got as a value here. My value was 0. Okay? If you take the square root of 0, you get 0. What happens? You take this value and you add 0, take this value and subtract 0, your value doesn't change, which also means 4 over 4, 1, is also your vertex of this. Your graph looks like this. There's the x and y axes. Here's your graph. Parabola's down to x equals 1, 0, and that's the vertex and the x-intercept. This also reveals where your vertex is. Your vertex is at the point negative b over 2a for x. You substitute that in to get y. In this case, the answer is 1, 0. Square root of b squared minus 4ac over 2a says how far to the left and right you go from your vertex to find the x and y to find the x-intercepts. You don't go any direction here. Plus 0 is 4, minus 0 is 4. You're doing plus or minus nothing. So if your discriminant is 0, that means your vertex is on the x-axis, which means you only have one solution. Unlike a parabola like this where it hits twice, or a parabola like this where it doesn't hit at all. Okay, these are your 3 different scenarios. This one happened because you had a discriminant of 0. So the 3 things I want to write here are, if your discriminant is 0, you're going to have one solution. So I could have done this entire problem. I had to rewrite it in standard form first, like this. But I could have done this entire problem without doing any quadratic formula and just evaluating the discriminant. It didn't ask me what my solutions were, it asked me how many I had. I would have just done b squared minus 4ac, and that equals 0. I already know how many solutions I will have. It's not 0, it's 1, for the reason I talked about. Now, if b squared minus 4ac is greater than 0, that means we're looking at a positive number in the square root. So let's say, just for the sake of whatever this wasn't 0, it was 10. Okay? Take the square root of 10, not a great number, but you take the square root of 10, and you add the square root of 10, and you subtract the square root of 10. Okay? Those are numbers. It's 3 point something. It's like pi. Right? This is an actual number. This will be a different number than this. This would be like a solution like this one. This would be 4 plus 10, or 4 plus root 10 over 4, 4 minus root 10 over 4. And 4 over 4 at x equals 1 would be where your vertex is, but this shows how far to the left and right you go. This is crossing at 2 different places here. So this would be an example of 2 solutions. I'm not going to actually evaluate that for you, but those are going to be 2 different numbers. Okay, they will not be the same one like your discriminant's 0. So if your number's positive, you're going to have 2 solutions it's going to cross twice. No matter whether those solutions are rational or not is beyond the scope of this problem. It's not asking you that. It's only asking you how many times will it cross the x-axis. Your final one is if it's less than 0, if it's a negative number. Now I want you to think about this one. Let's call this 10 again. Let's call it negative 10. Try that on your calculator. Square root of negative 10. It's going to say something like domain error. The issue with the world of real numbers is that there is no square root of negative numbers because there's no number that you can square to make negative. No real number, at least. In this case, there are 0, and I'm going to be very specific, there are 0 real solutions. You take second year algebra, you are going to learn about the entire complex number system, including imaginary numbers. And I'm not making that up, that's actually a real thing. In this scenario, there are no real solutions. There are 2 what are called imaginary solutions. But in this case, as far as solutions are being asked here, your answer would only be 1. There is 1 solution in this case, not 2, not none. None of these are not possible unless it's not a quadratic. Or, furthermore, maybe it's not possible because maybe you're looking at y's and not x's. I'm not sure. Maybe the answer is actually E in this case. But I don't think so. I think this is exactly what's anticipated. All right, so that's problem number 1. I have like 30-ish problems to go. I'm not going to spend that long on all of them. Okay, number 2, solve this factored form of A. It looks like it's a cubic function. Okay. Let me go back to number 1 for a second. Number 1 I solved by factoring first. Okay, it was very, very, very important that I got this into factored form to stretch and use my zero product property. Let me write zero product property here. In this case, I'm going to use A, B, and C because there are 3 products in play. There are 3 items here in play with our product. If A times B times Z equals 0, either A equals 0, B equals 0, and or C equals 0. I have 3 items here that are multiplying together. One of these has to be 0 to get 0 out. Again, try and multiply any 2 or any 3 numbers and get 0 if none of them are 0. It is impossible. So you get a split. If we're looking at a scenario where 3 times x equals 0, 3x equals 0, divide both sides by 3, you'd get x to equal 0. That is one of your solutions in this. Furthermore, you've never graphed a cubic before as far as I'm concerned, but this is also one of your x-intercepts at the origin. Okay? If you graphed this, I'll actually show you what the graph would kind of look like. It wouldn't be perfect, but you could take a look at it and just say, okay, it's making sense what it's doing, even though you've never seen a graph so strange. This is another quantity. Now, keep in mind, I'm not trying to figure out when x equals 0. I'm trying to figure out when these products equal 0. In this case, coincidentally, it was x. But I'm not saying that x equals 0 in all of these. No, no. I need to find out what number I substitute for x for this quantity to become 0, so I can multiply it by the others to get 0. In this case, 1/2, also known as 0.5. The third one, if x plus 5 equaled 0, x would equal -5. Those are your 3 solutions to this thing, and you have to find out which one matches here in terms of the In terms of this, 1/2, 0, -5, I think it's this one here, C. Okay. If you want to know what the graph truly looks like, and I won't have a perfect form of it, but it would look something like this. It would cross 3 times. It would cross at, make it green. It'll cross at 0. Let's say this was positive 1/2 right here, and let's say all the way here was -5. Knowing these, having graphed them a lot before in my life and having taught it, I know it does something like this right here. Okay, this is called a cubic function. So its tails go off in different directions as opposed to a parabola. It's a U shape. Okay, this has an x cubed in it, so it's going to do something like that. Kind of strange looking graph, but hey, you're going to be seeing it in Algebra 2. So just be ready. Yeah, that's it for this problem. Now, one thing you don't want to do for this problem is don't expand this back out. Don't be distributing and multiplying. You're in good shape. This is in factored form already. Go with that. You're well off where you're at. Number 3, write an expression for the perimeter of the given shape. We have a little arrow here, and they identify each individual part here. You just have to write out which one this ends up being. Now, perimeter is not area. Okay, perimeter is perimeter. You add up the sides. X plus X plus X plus 2X, that's 5X, plus X is 7X, plus X 8X, plus X 9X. 9 X's, here's a 6, here's a 6, that's 12. And that's all. There's some here that might trick you, that might make you think you're trying to find the area, and I'm sure one of these answers represents the proper area of this. Be very careful not to do that, and just make sure you understand that you are adding those things up like it. That's all I need to say for that problem, unless there's something else that I can think of. That's all. Number 4, simplify this. Now, by simplifying, it just means get the stuff out of parentheses, combine all like terms that you can, and kill it from there. All right, I'm going to go ahead and multiply these using the distributive property. Okay, I'm going to multiply 4 into 5x and 4 into -3. 4 times 5x is 20x. 4 times -3 is -12. Excuse me. All right, plus 8 is being multiplied into 3x squared and 5. Okay. So 8 times 3x squared is 24x squared. 8 times 5 is 40. Now we're going to combine like terms, and ideally I would prefer to write this thing in standard form, which would be descending order of degree, which means the x squared term goes first. Doesn't matter how large the numbers are, as long as the highest degree goes first. And I think that's how all of these are written up here. Next one's is the linear term. First one is the quadratic term. Now -12 plus 40 must combine. -12 and 40 give you 28, positive 28. So this will be last as the constant. We should look for an answer up here that says this. 24x squared plus 20 plus 28, or 20x plus 28 is A right here. Yep. Good thing about multiple choice is, you know, you might be able to land on your answer to feel more comfortable with it when you get the right answer, even though they might trick you into getting a different answer that they might have anticipated you getting, which would have been wrong. The x-intercepts of the parabola are boom, 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 boom. Okay. Want me to do it a couple different ways? Sure. I'll solve by factoring everything else. Okay, x-intercepts are values of x when y equals 0. I just did that on number 1. However, they had it set up for me where y was already equal to 0. So let's rewrite this equation with, instead of y, I have 0. And all my life I've just been used to writing it on the right side, so I will continue doing the same right here. Okay, my recommendation for these is, especially when you look at these answers right here, is this problem is probably factorable if you're landing on integer answers. So let's solve by factoring, first and foremost. Now, last time I did the whole generic rectangle mumbo jumbo. I don't know if you've been well aware of the diamond method and how that thing works. Personally, I do it mentally here, but you don't need to use a generic rectangle for something that has a 1x squared. 1 times -18 is still -18. Otherwise, you'd have to use that rectangle, and it would be a lot more difficult. There are ways to mentally do it, as I said, but this is what you're looking at. A product of -18, a sum of -7. Okay, if you're unfamiliar with trying factors out, let me kind of tell you how to filter out as many as possible. you're going to find factors of 18. There are 18 and 1, 6 and 3, 9 and 2. Okay. Now, which ones should be positive, which ones should be negative? Instead of checking these three, or these three pairs where they're all positive, 3 where they're all negative, 3 where one set is positive, 3 where the other set is positive, that's 12 total, I'm going to narrow it down to only 3 of them. How do I know which one works? Well, my product is negative, which means one number must be positive, one number must be negative. And I purposefully put this so that the larger numbers are on the left, smaller are on the right. Now, will the larger numbers be negative, or will the smaller numbers be negative? Well, your sum is negative, so your larger numbers will be negative. So we're going to check this case here. These three only. These are the only 3 things you should ever test in this case. You shouldn't test any others. Negative 18 plus 1 is negative 17. Negative 6 plus 3 is negative 3. Negative 9 plus 2 is negative 7. So it looks like your factors are negative 9 and 2. Also, I made mention of the generic rectangle. I don't need to use it because I also know that these factors will also be the 2 terms that split up over here. So I might have to use a generic rectangle problem later to show you what the difference is between the two. In this case, I can actually save myself time, and I have this right here. Okay, the zero product property, once again, splits these two up into 2 different equations. Either x minus 9 is responsible for being 0. If that's the case, x would be responsible for being 9. Or x plus 2 equals 0, so x equals negative 2. Now, these are solutions or roots to your equation. These are not the intercepts. Well, these are the intercepts, but the intercepts are coordinate points. These are the values of x when y equals 0. So your equation, your graph, crosses through the x-axis at these exact points right here. 9, 0 and negative 2, 0. And that's where you're looking at these things and you're saying, all right, now I know where my answer's at. Okay. You could also solve this problem using the quadratic formula and completing the square. I wouldn't use this completing the square, not in this case. I'll take out quadratic formula until I find a problem that is not factorable. How about that? Number 6, simplest radical form of this is. Now, simplest radical form does mean you only have one radical. And in this case, because it's a square root set of radicals, perfect squares are out of radical. Okay, that includes variables. Okay, in understanding all of this, I also want you to understand one more thing, and this is reversible. If I have a square root of a product of values, you can split that up into a product of the square roots of those values. Likewise, if you have one, you can do the other. So what I'm going to do is try and get my numbers as close as possible to each other and my variables as close as possible to each other. It's just going to make life a little bit easier. I'm going to split up the square root of 12 and the square root of x to the 5th. So first things first, I have this right here. This is not the way you must do it. This is kind of the foolproof method. There are a lot of other ways to do it, including in your head, which I've just done that now. In fact, to kind of prove that, I know my answer is going to be, I think it's going to be this one right here. Okay, so now I'm going to write my numbers as close to each other here and my variables as close to each other as possible, because I know that those are the things that are going to mesh together in any sort of case. Multiplication is commutative, which means I may reorder my values as long as I maintain their values, and I will still get the same answer out. Okay, before I get to this one here, 6 times the square root of 12 is not the square root of 72 because 6 is not inside a square root. These are both inside of square roots, however, and using this idea going from this way to this way, I can put these all under one square root hat. Meaning, the square root of x times the square root of x to the 5th is the square root of x times x to the 5th, which those can also combine into. Now, obviously, these are a lot of busy steps. If this is your only way of going about it, please do so. If there are other ways, go ahead and do that as well. Okay, square root of 12. That is not a perfect square. You are not going to use your calculator for this and say what it's about. I know it's between the numbers 3 and 4. That's not the point. The point is there's a perfect square factor that exists in this. Let's take it out. The square root of 12 can factor into 2 values here. Now, my recommendation for you is determine what the largest perfect square factor is of 12, in this case 4, and factor that one out. It'll save you a whole lot of time, and you will have completed this technically in just one step. The square root of 4 is 2, so this value is 2 root 3, 2 times the square root of 3. So this all becomes 6 times 2 root 3 times, okay, x to the 6th. The same idea. This will be a lot more straightforward. Factor out perfect squares. What are perfect squares of x to the 6th? X squared, and x squared. There are 3 of them. If these were all under square roots, what's the square root of x squared? It's just x. So this is x times x times x. X times x times x. I'll write that over here. Clean this up a little bit. 6 times 2 is 12. X times x times x is x cubed. And to write this kind of best, you want to write your radical last. Get the x cubed sandwiched in between here. You're going to get 12 x cubed root 3. That is simplest radical form. Probably not the simplest way to do this problem, considering I wrote step by step, but if you want to make sure that you're not losing track of anything, make sure that you probably do it this way. It's going to be a lot better for you that you get a problem right as opposed to something else. And considering this is multiple choice, there are other ways I could do this as well, although I might land on what are called false positives, is I could plug in some number. Here's actually what I'm going to double check for you right here. I'm going to plug in some number for x. Let's not do 1. Do something larger like 3. Okay. And I'm going to, let's do 2. And I'm going to see if I get the same thing up top as I would on bottom right here. Okay. 12 times 2 cubed times square root of 3. 2 cubed is 4. 4 times 12, 2 cubed is 8. 8 times 12, 96. I get 96 root 3. Here, if I plug in 2, I get 6 root 2 times the square root of 12 times 2 to the 5th power. Okay, this is not going to be a fun one to actually double check with. I'm sorry. Actually, I'll do the best I can with this. I'm going to factor out that 12 and get 2 root 3 again. So I would get, this is not fun to double check. 2 root 3 times 32 is inside there. So this becomes 6 root 2 times 2 root, what is it, 96? Okay, square root of 96 breaks up into, I know you can factor out a 4. See, what I'm trying to find is the largest factor. You can factor out a 16. I think that would be the largest one. So I can factor a 16 out of here, and the square root of 16 is 4, and there are 6 of these. So this will be 6 root 2 times 2 times square root of 16 was 4 times root, did I say 6 of them? 6. Which becomes, this actually leads me to another thing I should mention. 6 times 2 is 12, times 4 is 48. 48 times root 2 times root 6. Okay, from here you can either do one of two things. Either merge these into root 12 and do square root of 12, which is 2 root 3. Or you can break up root 6, because it's not a prime number, into root 2 times root 3. And now you have a scenario where the square root of 2 times the square root of 2 merge together and give you 2. So 48 times 2 times the square root of 3 gives you 96 root 3, which is also the same thing as I got in the other one. Now that could have been a false positive, but I'm willing to think I got the right answer there, either side. It's probably also why you don't want to just plug in numbers. My other recommendation to you is going to be just plug in numbers for both this and this and see which one comes out the same. One, you might lead into a false positive. 2, that took a long time. However, you probably will have the calculator, and you can just type them in straight up, see if the decimal is the same. But it's probably better you know how to simplify radicals, because at some point you're going to have to know to do this by hand. Okay. Number 7. Which of one of these parabolas opens down? First things first, it does have to do with certain numbers being negative. Okay. Second things second, it has to do with which one is negative. Okay. Third things third, to figure that out, it's probably best you write them in standard form. This is written in standard form. And by standard form, I mean descending order of degree, squared to first power to 0 power. Standard form, not standard form. Let's see what this one is in standard form. It'll be 4x squared plus 3x minus 5. Okay, to be even more blunt here, Ones that have no negatives whatsoever, you can kind of just say are obsolete. Definitely won't be one that has no negatives whatsoever. This actually has everything to do with your quadratic term being negative. Notice these ones have negative constants. That just shifts your graph more downward. These have nothing to do with it here. So it's between these two. And you can graph them somehow, plot them, and see which ones. This 3 is a negative number, and that has everything to do with the way this graph will go. The reason why we do descending order of degree is because that degree completely dominates everything else in this graph. No matter how small the scalar factor is, as long as it's negative, it is negative, it will supersede everything in these ones. No matter if these numbers were 10,000 or whatever else, it would still go downward. So this one, negative quadratic coefficient, equals opens downward like that. All of these are parabolas. Even the ones with less terms, like these two, only one set truly opens downward. It's going to be that one. How else would you check? You have to plot a table and stuff. Otherwise, you're going to have to be very wary of that. Number 8. Find the product. 3x plus 2 quantity squared. All right, let's begin with what it's not. Okay. A plus b quantity squared is not a squared plus b squared. Okay? This is true for a product, and it's true for a fraction. The easiest one to explain, I suppose, is the product. If you are multiplying by something and squaring it, you are counting how many times you are multiplying those things. So that seems to make sense. Addition is not quite the same thing. It's when you're multiplying the same thing by itself. Well, a plus b times a plus b is not a squared plus b squared. There are those two terms, but there is a linear term in the middle. So a couple ways to go about the actual. Now, I'm talking about a plus b. I should be talking about 3x plus 2. But this can actually give you a more general. Oh, you know what? Yeah, I'll give you the more generalized formula first. A plus b times a plus b. There are a couple methods in which you can do this. We've talked about the arrow method. Okay, you multiply every term in one quantity with every term in the other quantity. No one term multiplies with the same or with terms in the same quantity. You're going to multiply a with a with b with a, and b with b. And for the sake of ease of everything else, I'm going to write these alphabetically. A times b is ab, b times a is ab, and then b times b is b squared. So you're left with a squared plus 2ab when you combine like terms, plus b squared. This would be more important actually for something when we talk about perfect square trinomials in general, completing the square, stuff like that, in terms of learning it for the first time. So it's not this, but it is this. So let's change this to a plus b quantity squared, like that. All right, now we have a settled thing right here. So this is what it always becomes. So I could plug things in, and that would help, but I think it's better to just actually distribute it normally. Let's bring this up. Okay. I could do both ways. 3x plus 2 quantity squared. Let's go ahead and actually officially do this one. That is 3x plus 2 times 3x plus 2. Okay. Another way to go about these, let's say you weren't good with the arrow stuff. Okay, you can use what are called generic rectangles. By that it means these become the base and height of a rectangle. They aren't alike, so you separate them into different slots. So for instance, 3x plus 2 might be the base, but also 3x plus 2 is the height. This is more than a generic rectangle, it's a generic square. And you find the areas of these individual portions, and then you combine like terms as needed. So 3x times 3x is 9x squared. Okay, don't forget about the squared, x times x. 3x times 2 is 6x. 3x times 2 is 6x. And keep in mind, I did talk about these being rectangles. If this is 3x, this is also 3x up here. That's why I'm doing 3x times 2. And then 2 times 2 is 4. So you add all those up together, you're going to get 9x squared plus 12x plus 4. And that's your final expanded version of that one, which it looks like it's part E, or it's solution E right here. Now, if you wanted to double check what the a squared plus 2ab plus b squared, you could try that. That actually might be even harder for you, though, even though you're plugging things in straight up. We got to square 3x we're going to do 2 times a times b, and then you're going to square the number 2. 3x squared, once again, is 9. So again, the reason why you might screw up is you might forget to square the x or something like that. 2 times 3 times 2 is 12. There's the x. 2 squared is 4. So you still get the same thing. Depends on which way you go about it. But yes, perfect square trinomial factored into here. Once again, that's good for completing the square. Now the generic rectangle is one way I could have done this. I also could have used the arrows as well. Multiply 3x with 3x, 3x with 2, 2 with 3x, and 2 with 2. Got the same exact thing. Number 9, which equation describes the line that contains the points -2, 5, and 2, 1? For me to do this, I'm going to draw a graph to kind of get the lead in as far as what it is we're trying to do. Okay, we are trying to find out how this line, what slope this line has, and how this line crosses through the y-axis, meaning where it crosses through. Now I'm not going to make it perfect. I'm just going to do -2 up 5. That's fine, and then over 2 up 1 like that. We're trying to find out which line, just to be generalized about it, this one is representing. Okay. By that, we have to figure out what is the slope, how much is it going this way, how much is it going this way, and also where is it crossing here. This is your B. This is your change in y over your change in x, which is your m. These points specifically were -2, 5 and 2, 1. Okay? Now, oh, and finally, we're going to write it in y equals mx plus b form. Okay, now, b is something that you know, unless you drew this perfectly and you had it on graph paper, that's something you could actually find. But let's go ahead and let's figure out the slope and use the y-intercept based on that. So this is the run. This is from -2 to 2. The difference between -2 and 2 is 4. That's how much you have to count to go over there. And down from 5 to 1, this is a fall of 4, so this is going to be -4 right here. Your slope, your change in y over your change in x, is -1 over 1, or better yet, just 1 right there. So as far as your equation, you know that it's at least y equals -1x plus b. Okay, we still have to find out b here, and it will be based on one of these pairs of x, y values that we know is true, either -2, 5 or 2, 1. Either or will work. For smaller and more positive numbers, let's go ahead and plug in 2, 1, but either or will give us the same value. And you know it's going to be somewhere between 5 and 1. In fact, you probably already know what it's going to be, right in between 5 and 1. But you plug in 1 for x, or 1 for y, and be very careful because 2 is written on the left. You might actually write that on the left over here. Be super careful with that. You're going to get b equals 3. Now, b would have equaled 3 no matter whether I plugged in 2, 1, -2, 5, or anything else that I knew was the solution to this equation. It's going to be the same y-intercept. That's just how the rates work. So your final equation is y equals -1x, or better yet, -x, plus 3. Looks like that. That's right there. That's C. If you didn't want to do this using a graph, then you have to find the slope in some other way. Now, we did it kind of more of a counting measure, but I did mention the word difference, the difference between the numbers 5 and 1, the difference between the numbers -2 and 2. Well, slope is change in y over change in x. It's the difference in your y values over the difference in your x values. And it doesn't matter which set you choose first as long as you choose the same set for both first, meaning if I chose this first as my first x value for x2, then I have to choose this as my first y value right here. So I have to do 1 minus 5 over 2 minus -2. And once again, you get your same thing. The difference that you'll make if you accidentally do 2 minus -2 and then 5 minus 1 is you'll get an opposite slope that you wanted, which is no good. You want it to be the correct slope there. So change in y over change in x, but like I said, the visual is very nice for that. The whole thing with the b value, once again, is you don't want to just estimate and say, oh, look, it looks like it's crossing through there. Because you know what? Every so often you'll get a decimal value. Obviously, these answers didn't look like such. And actually, here's where you can work on the multiple choice. If you know how this is graphing like this, you know it can't be crossing at -1, -1, or -7. You know it has to be between 5 and 1, so you know it's going to be 3. So the question is, which slope is it? Obviously, it's going to be the negative slope. The positive slope would have gone this way, right there. So you can actually get the answer quicker ways using the multiple choice. Even if you don't know how to do it, that's not something I'd recommend because you're trying to learn how to do the stuff. Furthermore, for multiple choice, if you want to see truly which line contains it, plug these two xy values into all these. I have no doubt that some of these actually work for some of them. For instance, if I plug in 2, 1 into this equation, 1 equals 2 minus 1, heck yeah, that works. 1 equals 1, that checks out. But does it work for both? Negative 2, 5. 5 equals negative 2 minus 1. Oh, 5 equals negative 3. That one doesn't work. So you know it's not part A. Part B, you do the same thing and figure it out. Not until you get to C do both actually work there. So C is the final answer for that. A lot of different ways to look at it. Hope we just tackled enough of them there. Let me do one more, actually. I'm going to use what's called point-slope form. Point-slope form looks like this. Okay. And what happens here is you find your slope first, just like we did before. Your slope is negative 1. And then you plug in one of your xy values in directly into this equation. Now, it doesn't make this any easier of a problem because you still have to get everything moved over. But plug in negative 2, 5 or 2, 1. This time I'm going to do negative 2, 5. Plug in negative 2 for x1 and 5 for y1, and you're going to get the equation y minus, was it 5? Equals negative 1, that's your m, times x minus negative 2. Okay? And that gives you y minus 5 equals negative 1 times x plus 2. Distribute the negative 1 and add 5 to both sides. You'll still get that in slope-intercept form. This would have been an acceptable answer. I think this one would have been an acceptable answer. Problem is, it's multiple choice. And this wasn't one of the answers written on multiple choice. So you'd be looking at this and saying, yeah, but it's right. Yeah, it is, but which one's equivalent is what they're asking. That's slope-intercept form. Furthermore, you might get one where all of them are in point-slope form, not in slope-intercept form. So you might want to know how to do this one as well. Okay, 3/7 is equivalent to which of the following? All right, well, I just made mention of this before. A over B quantity squared, yes, is indeed A squared over B squared. If you don't trust me on that, and I trust maybe you can use a calculator most points, try and type 3/7 and square it, then try and type this and, you know, this number, 3 squared over 7 squared, right here, which of course is 3 over 49, or 9 over 49, which looks like then that's part D. If you didn't fully know that, that's okay. What you can also do, anything squared is anything times itself. A over B times A over B. Now what you'll have to recognize is that's A over B times A over B written like this, and you multiply straight across. A times A over B times B, which is A squared over B squared. So once again, you can still get there. 3 times 3 over 7 times 7, that is 9 over 49. You'll get there. Now, although this has nothing to do with the multiple choice, what if there was an answer that was, let's say, instead of this, let's say it said 18 over 98. Okay, the reason I said that is because that's this number doubled times this number doubled. This is still the same decimal. However, if there was choosing a best answer, you would choose the one that's most simplified, this 9 over 49. So the next question you might ask is, can this number be simplified? And the answer to that is not if this can't. If this can't be simplified, 3/7, then this can't be simplified because you are squaring the number 3/7. How can you simplify something if you're multiplying it by the same thing? Right? So, no, this cannot be simplified, so no other answer would even be appropriate. This is not the same thing as 3 over 7. They are two totally different numbers. Number 11, solve x plus 7 quantity squared equals 0. A lot of different ways you can do this. I could solve using quadratic formula even if I'd wanted to. It'd be kind of strange to do. Let's just rewrite it out one more time. Okay. Maybe you're not comfortable looking at it in this format, though. Maybe you do need to look at it as x plus 7 times x plus 7. You're one of those guys with the formatting stuff. You say zero product property. I need to look at the two numbers here. Obviously, they're the same thing. If x plus 7 times x plus 7 equals 0, and we just did this, I think, on the first problem. Either x plus 7 equals 0 or x plus 7 equals 0. So x is negative 7. There's only one number that can give you 0 there. Same thing here. The backwards approach is you take the square root of both sides. Okay, and x plus 7 is 0 in that sense. So no matter what you do, you're just going to be getting one solution. It's negative 7. Positive 7 doesn't work here. 7 plus 7 is 14. 14 squared is 196. That's not 0. This is the only one that seems to work there. Not 0 either. 0 plus 7 is 7. Okay, so you could have you know, you could have expanded this like that. You could have solved using quadratic formula. Seems like a waste of time. It really does. I don't anticipate anyone will do that. I'm just saying that's not out of your realm to do. Number 12, let's simplify this mumbo jumbo right here. You have some things in parentheses, no problem. What I'm going to do, I'm going to rewrite this. And then I'm going to rewrite it one more time, and when I do, I will make sure that any numbers are together. Well, actually, I'll rewrite it one more time, even so, with little dots right here. I think perception's everything, and when you have this here, let's write them all with dots. You're saying, oh, look, everything's multiplying with each other. So why don't we just reorder them? Meaning, why don't we get the numbers together? Let's get 8 and -4 together and 2 together. Then let's get x and, sorry, I thought someone knocked on my door. Let's get x squared and x squared together. X squared, x squared. Because now everything's where they kind of need to be multiplied with. 8 times -4 is -32. Times 2 is -64. X squared times x squared, 2x is multiplied, times another one, times another 2. That's 5 of them. There you go. -64, x to the 5th, d. And again, if you want to double check, best you can do is plug in a number for x. Try and not do 1 or 0. Once again, that can lead to a lot of false positives. But you can plug in 2 or 3 or something and see if you get the same number out here as you would have here. Number 13, let's simplify this one right here. It's basically about combining like terms. And sometimes you'll get things written as so. And you will, you'll have to get it in standard form or something, so you just have to combine like terms. Well, the x squared, oops, here we go. Well, the x squareds cannot add with the x's here, but these two can go together here. So I'm going to put these next to each other. Here's the real trick. And I don't think there's actually necessarily a real trick based on the multiple choice questions. But I'm not going to put 8x squared minus 2x squared. I know there's a minus there, but that has to do with the 4x. This 2x squared is positive. This should be 8x squared plus 2x squared. This is minus 4x right here. 8x squared plus 2x squared is 10x squared. And that's minus 4x. Problem's a little hokey because the only answer that has 2 terms is this one, and we know these can't combine, so that's kind of strange that this was the only one. I would have preferred they also had one that had 6x squared minus 4x, or 6x squared plus 4x, because 6x squared would have been from 8x squared minus 2x squared. And a lot of people do that. They put minus and they find this one and they subtract them. Don't do that. The 2x is a positive number, 2x squared. Okay. That's 13. Number 14, 3 to the 8th times 3 to the 6th. I'm going to write this out. 3 to the 8th is 3 times 3 times 3 times 3 times 3. 8 of them. Times 6 3s. How many are being multiplied together? 14 of them. So it's 3 to the 14th. Was that the easiest way to do that? No. There's an easier way. This is 3 to the 8th. It describes how many times 3 is being multiplied together, 8 times, and it's multiplying with how many times 3 is being multiplied together here. Okay, well, some people might think, oh, 8 times 6, it's 48. Yeah, but you're not multiplying those numbers. Those numbers determine how many times the number is being multiplied, so you add those together. Okay? So that one, like I said, that's the easier way to go about it. Just add these two together. What was I going to say about that? Ba-boom, ba-boom, ba-boom. Oh, just a general format. A to the x times a to the y power equals a to the x plus y power. That's all. Same with division. When you divide, you're canceling out some of the ones you had before, so you would subtract. You wouldn't add. That's all. So 3 to the 48, Oh, furthermore, these don't combine in any sort of way like that, too. Number 15, simplify 5x minus 2 minus the quantity 8x minus 6. So first thing I want to do is get these things out of parentheses. Now, I can't just get them out of parentheses. It's rewrite them without parentheses, meaning some things might change. The first quantity does not change whatsoever. This is still 5x minus 2. It's being multiplied by 1, basically. But this quantity is being multiplied by -1. if you think about it. So you distribute a negative 1 into here. Negative 1 times 8x is negative 8x. I think most people get that one. What they forget is this negative 1 also gets multiplied by this negative 6. This becomes a plus, not a minus. So if I wanted to rewrite things so they're next to each other, I would do this. Okay? Keep the signs as they're supposed to. This minus goes here. This minus goes here. 5x minus 8x is negative 3x. Excuse me. And negative 2 plus 6 is 4. I promise I'm not tired. I just got a little yawn. So that's B. Notice where A came into play here. What if you did put minus 6? You would have had negative 2 minus 6. That would have been negative 8. You would have gotten A as an answer, and it would have been incorrect. Okay, so be very, very cautious about this thing. Multiple choice wants to trick you. It wants you to try them. Once again, you can always double check. Try and plug in the number 2. See what happens there. See what you get. You will not get the same thing as you would up here. Number 16. Solve these two radicals. Okay. Haven't looked at one of these problems with anyone in quite some time here. But here's the thing behind this. And there are a lot of things behind this problem. More than you can imagine. Ones where I'd look at the graphs as well. Okay. But you have isolated radicals on both sides of the equation. I know you just heard isolated radicals and you said, what? A radical is the square root sign. That's rad, dude. Now this one is square root. Some of them are cube roots and whatever. That's why I don't know why, but that's why they also call them radicals. Isolated means they're on opposite sides of the equation. Now this is huge. There's a big reason behind that. Okay. Remember back in this problem when I said here that we can take the square root of both sides? I can only do that because this was a term that was isolated by itself. I think I also made mention way back in problem number 1 that I cannot just take the square root of this guy right here and leave the others be, or I can't just take the square root of all of them and cancel one thing out. The term needs to be isolated for you to be able to do something like that. And outside of doing all the math behind it, I need you to trust me on it. If you multiplied the square root of whatever and squared it, you can try and FOIL it as well and see what you get out of it. In this case, it's going to be cleaned up because these are isolated. So I can square both sides here, and the square root of this guy, quantity squared, is just this guy, this 4x minus 7. Okay, that's it. Square root of 6x minus 11 quantity squared is just 6x minus 11. Okay, the square cancels out the square root. Subtract 6x, add 7. You'll get negative 2x equals negative 4. Divided by negative 2, you get x equals 2. Now, the final thing with this problem, which I think everything will be cleaned up because there's only one solution here as well, so you just want to double check your work. You want to for most things, but when it comes to square roots, there's something else that's a little picky. Don't know if I can explain it fully in this case here, but double check and make sure that you get numbers that actually not only equal the same thing on both sides, but also works as an answer. Okay, as the original thing said, 4x, now here you go, 4x minus 7, that's 8, minus 7 is 1, square root of 1 is 1, and then 6 times 2 is 12, minus 11 is 1, square root of 1 is 1, so 1 equals 1, it checks out. Some things will get a little squirrely, and I'm not sure if we're going to run into any of those problems here, but this answer here is D. Furthermore, look, it's multiple choice. You could plug in any of these numbers and see if any of them work. Only one of them will work. Number 17, simplify. All right. So in terms of simplification, they also do something else here. It seems like the negatives are gone with these exponents, and that's a huge thing about this. Don't leave negatives in your exponents here. All right, my recommendation for those who have trouble with perception here is split up numbers with numbers, A's with A's, and B's with B's. Separate them by multiplication because that's exactly what's happening. There's absolutely more than one way to do this problem. There are faster ways, there are shorter ways, there are easier ways, there are harder ways. There are some ways based on the problem type. This one with the negative probably helps promote something for me. 15 over 5 is 3, or 3 over 1. That might be important if there's anything in the denominator still, which it looks like there will be. I made mention of the fact that if you have division of exponents, you should subtract them afterward. This was a negative 4. I should be subtracting 2. That's a to the negative 6th power. Now, if a to the 6th power is a times a 6 times, a to the negative 6th power says how many times you divide by a, starting from 1. You divide by a 6 times from 1. So this number will be 1 over a to the 6th power. Okay, a to the negative 6th power is 1 over a to the 6th power. This last one here, this is also division, b to the 6th minus negative 8. That's b to the 6th plus 8, which is b to the 14th power. So you are, this is strange, you are dividing 1 over b, which is multiplying by b, 8 times from there. This is times b to the 14th. Ugh, that's over 1. This is over 1. If you wanted to multiply, you can multiply back straight across, and you'll be in good shape. That equals 3 times 1 times b to the 14th. That's 3b to the 14th over a to the 6th power. Again, that's only one way I could have done that problem. A lot of other ways. Once again, you can plug in any numbers you'd like. Make sure that they work out. But that one should be fine. That looks like it is C. Okay. Number 18, which equation has an x-intercept of negative 3? What they are asking is, when y equals 0, which one gives you x equals negative 3? So you can plug in negative 3 into these and see which one gives you y value of 0, or you can substitute 0 for y and figure out which x value gives you negative 3. This is written in what's called standard form. It's not even in slope-intercept form, but that's okay. You're looking for x-intercept anyway. Substitute 0 for y for all of these. How? Or how does that ease things up? 6 times 0 is 0. Okay, this goes away. Negative 4 times 0 is 0. That goes away. 6 times 0 is 0. 6 times 0 is 0. Negative 6 times 0 is 0. Take a look. All you got to do is figure out which one gives you an x value of negative 3. And it looks like it will be A, actually. X equals negative 3 on A. So that one has the x-intercept of negative 3. Now, once again, how did I do that? The x-intercept is the value of x when y equals 0. The reason I colored these all purple is because any number times 0 is 0. So it gets erased from this whole idea here. I don't need the rest in here. If you want x-intercept for all these, this one's x equals 6, x equals negative 6, x equals 6, x equals 6. This one has x equals negative 3, which means it has a point of negative 3, 0, by the way. And these are linear equations. They're just not written in y equals mx plus b form. That's okay. You can do that, but you don't need to. Number 19, simplify x to the negative 2nd power cubed. Once again, a lot of ways you can go about this problem. Maybe I'll look at just a couple of them. Okay, x to the negative 2nd power, as I talked about before, it's 1 over x to the positive 2nd power. And if you look at what we just talked about before here with kind of distributing the exponent, that's 1 cubed over x squared cubed. Well, x squared cubed is x squared times x squared times x squared, which is x to the 6th power. So this is 1 over x to the 6th. That's but one way you can do this problem. Second way you can do this problem is kind of recognizing how this part works right here. When you raise an exponent with another exponent here, you end up multiplying these two because it says how many times you're multiplying this value out. You're multiplying x squared 3 times, which gives you x to the 6th. So you could have done the same thing from the very beginning. This equals, x negative squared third equals x to the negative 2 times 3 power, which is x to the negative 6th power. Well, x to the negative 6 isn't an answer on here. Furthermore, they don't want negative exponents at any one time. So it looks like you'll be getting that as an answer. Same thing, twice. A. That's it. Once again, you can plug in numbers in your calculator and play with them a lot. Number 20, solve this equation. What's great is you get to look at these solutions and say, this is factorable. If it wasn't factorable, you'd be looking at some weird irrational value. So at the very least, you know it's factorable. Pretty nice. The other thing about these answers are they should really put them in curly braces to indicate this is a set of values. Okay, this is not an x comma y value. These are two different values for x. This is x equals this or x equals that. Okay. Now, this is a quadratic equation, so that makes sense that these are what they can be. So I made mention once, I don't want to solve by completing the square with this one. It's going to be a little too hectic if I do it that way. So I'm just going to solve by factoring on this one. Maybe another one I'll use quadratic formula if I have to. If I solve by factoring, then I'd like to subtract this 22 over to this side. So I'd like to have 0 on the right side. If I have 0 on the right side, that means I can factor and use 0 product property over here. So what I'm looking for are two numbers that multiply to become negative 22 and add to become 9. The only factors of 22 I can come up with are 22 and 1 and 11 and 2. Now, as this is negative, 1 has to be negative, 1 has to be positive, and this positive sum is bigger, so that means that your smaller number must be the negative one. 22 minus 1 is 21, 11 minus 2 is 9. It looks like it's going to be 11 and negative 2. And because your quadratic coefficient is 1 here, this will be straight up x plus 11 times x minus 2. If that's the case in zero product property, if x plus 11 equals 0, or if x plus 11 times x minus 2 equals 0, then either x plus 11 equals 0, in which case x equals negative 11, or x minus 2 equals 0, in which case x equals 2. So your solution set contains 2 and negative 11 like that. So one of the answers looks like this, or negative 11 written first. Looks like it's this one right here. So negative 11 and then 2. That's D. Okay. Number 21, what is the length of the unknown side of the following triangle? You can't measure it. It's not necessarily drawn to scale. You can make note of this right angle symbol, which means this is a right triangle. And in a right triangle, there's a special relationship between two legs and their hypotenuse, where if I square this number and add them together, that will equal the square of this number here. Now, it is not the same as A plus B equals C. No, no. That can't be the case in a triangle. You cannot have the sum of two legs equal, or sum of two sides equal the third side. They always have to be greater. But A squared plus B squared indeed does equal C squared. So if that's the case, let's substitute. Oh, by the way, A and B represent your legs. C represents your hypotenuse. 7 squared plus x squared, the unknown, equals 12 squared. 7 is 49. X squared is unknown. 12 squared is 144. Subtract 49, x squared is, what, 95? And last part, x equals the square root of 95. Okay, now, that's one of my answers on here. This should be in millimeters. There are times where, it looks like it's not here, but there are times where you can simplify your radical. By that I mean factor out the perfect squares. We just talked about that before. Looks like this is not the case here. Looks like this ends up being our answer. I imagine, as I'm looking at it right now, it looks like it's true. I imagine you get 193 by doing 7 squared plus 12 squared equals x squared. Remember, 12 is your hypotenuse. It's the longest side of here. It's not going to be one of the ones that's added with the squares in here. It's not going to be this. No, that's wrong. X should never be longer than the longest side, so that one's going to be wrong. So be very, very careful about those when you're doing them. All right. Okay, which of these can neither be an x-intercept nor a y-intercept? Well, a y-intercept is a value of y when x equals 0, which means this one has x equals 0, this one has x equals 0, so those ones are out, meaning these can be y-intercepts. X-intercepts are values of x when y equals 0, which means this one's out and this one's out. This is neither an x-intercept nor a y-intercept. It's not a value of y when x equals 0, a value of x when y equals 0. On the graph, it's right here at 5, 8. Boom. An x and y-intercept cross the x and y axes. This one does not. That doesn't mean a line that crosses through these axes can't cross through here as well. That's fine. You can do that. It's just not an intercept. Kind of a bizarre question. You know, considering question number 1 was so huge and it involved using x-intercepts, this one was really mundane in comparison. It was actually kind of funny. All right, number 23. Solve for this. I'm sure there are ways you could look at this and guess and check and say, yeah, I know what that is. It's going to take a second, though. So let's do it solving with algebra. Let me rewrite the problem. I don't know why I always want to rewrite the problem. I think just because you need the next line to be able to see what's up. Okay, you're multiplying 2 by a number, and you get 8. Obviously, this number must be 4. How do you know? Divide both sides by 2. All right. So the square root of x minus 3 is 4. Now, what I'm about to do here is get this x minus 3 out of the radical. The way of doing that is to do the inverse of square root, and that is to square both sides. Now, as I square both sides here, I'm going to get x minus 3 equals 16, because 4 squared is 16, and add 3, I'm going to get x equals 19. And that's it. To double check, let's take a look at that again. 19 minus 3, oh, it's this one. 19 minus 3 is 16. Square root of 16 is 4. 2 times 4 is 8. That's it. Like I said before, with different things, multiple choice, you can probably substitute numbers in and see which one works. The only ones that give you actual perfect squares are this one, and this one. The other three don't even give you perfect squares, so that's it. Number 24, the first step in completing the square of the quadratic, boom, 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 is what? Interestingly enough, I would say there's more than one way people write the first step, but I would say that there's only one that actually replicates the first step truly, and that is this. What completing the square means is that you need to make a perfect square trinomial out of this quadratic function here. Let's say your thing isn't factorable, and by and large it might not be. Okay. In fact, I don't think it is. If your thing is not factorable, then you want to find a different way to solve it, either using quadratic formula or what quadratic formula comes from, called completing the square. It is a way of saying, timeout, I'm going to go backwards here for a second. Let's say I subtracted 2 from both sides. Okay, the ideal thing would be to make this factorable and set it equal to 0 for zero product property. The problem is, as I stated, I don't believe this is factorable, and furthermore, if you don't put it in as equals 0 like this, you cannot get zero product property. There's no such thing as 2 product property, so we need to find another way of going about this. Meaning, we can't just make this into some rectangular factor. We have to make it a perfect square. Now, negative 12 is obviously not the constant that we need for these two guys to make a perfect square. It has to be something else. So the first step I'm going to do is add 12 to both sides. The reason for that is because I need another number to add in right here. In fact, this is going to answer the question, but I'm going to keep going with this actual problem and solve it for you as well. We need to add in some other number right here to complete the square, to make a perfect square trinomial. And whatever we add on this side, we're going to add on this side. But ignore the red, look at the black. X squared minus 8x equals 14. See, this is the right away wrong one to do. This maybe comes later. This maybe comes later. This looks a little bit like what the second step would be. Okay? This looks like the second step, but the first step looks like it's this one right here. Okay, the second step is about adding in what value gives you a perfect square trinomial, which is, like I said, where some of these steps, these might be the right steps. Well, actually, this is the wrong step. This is a step for factoring. This is a little bit incorrect. Yeah, all these other steps are right. It's just not the first one. So the first step, I wonder what they mean by the first step. Is it the first step in solving this problem or the first step when you complete the square? Now I'm going to start completing the square. Sorry, I'm talking to myself a lot. In completing the square, I won't overspeak about how you do it. I'll just state the process from there. You want to make sure you learn it. As long as this x squared coefficient is 1, you take the value negative 8, you divide it by 2, that becomes negative 4, and you square that. I think I already mentioned that before. Negative 4 quantity squared is positive 16. So we're going to add a 16 right here. And to keep this equation balanced, we're going to add a 16 right there. So this is ideally the second step. The first step was here, second step was here. As you can see, that step comes into play as part B because 14 plus 16 is 30. So we're going to get to this statement right here. That would be what part B is. That's, I guess, the second step. The third step comes into play where we have now made a perfect square trinomial on this left side, and that's perfect because now we can factor this into something quantity squared, which means we can take the square root of it. This becomes x minus 4 quantity squared. Negative 4 plus negative 4 is negative 8. Negative 4 times negative 4 is 16. Okay. Taking the square root of both sides here, you're going to get x minus... Now, I know we've already solved the problem. I'm just going above and beyond. I think I've already made mention of this, but this is going to be plus or minus the square root of 30. We're going to that extreme right there. And I don't think that can be simplified. So we're just going to write it as that, plus or minus the square root of 30. There will be two solutions to this, either positive square root of 30, or either positive or negative version of that value that x minus 4 can be. Add 4 to both sides, x equals 4, plus or minus the square root of 30. Now, if you don't really believe me about this, think about what would happen if you actually did do this with quadratic formula. You would get the same answer. Okay, there you go. It's number 24. This was the answer. I just did more for you. Number 25, simplify. Okay. This quantity is being squared. This quantity is being cubed. Let's get those out of there first, out of that squared and cubed, by squaring and cubing each individual part. So 5x squared quantity squared is 5 squared times x squared squared times 3 cubed times x to the 4th cubed times y cubed, like that. Oh, that's a lot. 5 squared is 25. X squared squared is x to the 4th. 3 cubed is 27. X to the 4th cubed is 4 times 3, so that's 12, x to the 12th, and y cubed is y cubed. 25 times 27, that's 2 more than 25 times 25, which is 625. 2 multiples of 25 more is 50 more, so that's going to be 675. X to the 4th times x to the 12th is x to the 16th, and y cubed is right there. There we go. That was an easy one. Looks like it's this one right here. It's the only one that starts with 675 even. So once again, multiple choice can save you at times as well. I won't go beyond that problem. That's it, and that's all. Number 26, which equation represents the line shown in the following graph? Okay. The best way to go about this graph is determine what the y-intercept is if you can. It looks like you can. This crosses at 0, negative 1. You're going to have to trust the graph the best you can. Second thing is to find another point on the graph. A good point, like this one, very legible, 3, 1. 3, 1, 0, negative 1. Okay? You could even pick this point down here if you can tell that it actually reaches it, negative 3, negative 3. You need 2 points to determine the slope of the line. You can use either of those 2 points to determine the y-intercept. It looks like this is already well in agreement with what the y-intercept is. Looks like it's negative 1. Well, actually, if you look at some of these other ones, that's not necessarily true. In fact, this one does not have a y-intercept of negative 1. I know because I'm going to divide everything by 3 to get a y-intercept of negative 1/3. So it definitely can't be this one. Okay. Other ones I can cross out from here. This slope is positive. I have a positive rise with respect to a positive run. So I know my slope will be positive. It can't be negative. So I know what it also can't be. C or B. Don't waste my time. And I don't know why I'm playing the multiple choice game. I should teach you how to do the problem itself, but I'm explaining why these ones aren't it. So I think that's logical talk right there. You're going to find the difference between the values negative 1 and 1. That'll be the difference in your rise. That is 2. The difference in your run is from 0 to 3. That is 3. So you're rising 2, you're running 3. So it's between these two. Make sure a rise goes over run. It's going to be 2/3. This one right here. Your slope is 2/3. Your y-intercept is negative 1. So therefore, in y equals mx plus b form, it's 2/3 x minus 1. Now this problem could have ended up being an answer like this one. If you wrote it in slope-intercept form, this one would be like this. Obviously, this is not the answer. I'm just saying that don't short yourself on something written in standard form. Write it in slope-intercept form and see what it becomes. Obviously, this is not the same answer as that other one. The wrong slope and wrong y-intercept. So it's still not correct, but don't short yourself on that one. If this one didn't show up here, this one might be the answer. Number 27, x minus 5 quantity squared is x minus 5 times x minus 5. If I wanted to go straight up, multiply each term by the other terms in the quantities, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is 25. Negative 5 times negative 5 minus 5, negative 5x minus 5x is negative 10x and plus 25. That's it and that's all. I'm not going to spend a lot of time on these kinds of problems after we've done ones like them. You can use generic rectangles. You can use a squared plus 2ab plus b squared, anything like that. That'd be pretty straightforward. But there it is. Like I said, you can always double check. Plug in a number. Plug in 2. See what you get. I'll do it for you. 2 minus 5 is negative 3. Negative 3 squared is 9. 2 squared is 4. 4 minus 20 is negative 16. Negative 16 plus 25 is also 9. Good. Number 28, evaluate the opposite of x squared when x equals negative 8. All right, this one I'm going to spend a couple minutes to talk about because this is where people make the most mistakes. First of all, let's say it said evaluate x squared when x equals negative 8, just to make sure we understand what's happening here. Okay, if I evaluate x squared when x is negative 8, I'm going to substitute negative 8 in for x. Notice how I normally always use parentheses when I substitute. This is for good reason. Negative 8, quantity squared, is not the same thing as the opposite of 8 squared. The difference you see is the parentheses. The difference that it's making is the order of operations. This number is negative 8 times negative 8. This number is the opposite of 8 times 8. This number is 64. This number is negative 64. Okay? You try both on your calculator, you would get the exact same thing. The difference is exponents come before not only subtraction. You can think of this as subtracting 8 squared. It also comes before multiplication. If you want to think of this as negative 1 times 8 squared, all right, you're doing 8 squared first, and you're multiplying by negative 1. So either or, whichever way you put it, the subtraction or the negative comes last. Parentheses dominate everything else, and everything within the parentheses dominate. So this subtraction, or negative 1 times 8, whichever way you want to look at it, comes before you square it. I'm squaring the number negative 8, so I'm multiplying by itself twice, so it becomes 64. This problem, however, is about the opposite of x squared. So let me make sure that when I substitute negative 8 for the opposite of x squared, I still keep parentheses in mind. Some people forget that just because this has a negative sign here, doesn't mean you just do it once. X is right here. It's after the opposite. We're going to take the opposite of x, negative 8 quantity squared. Now, one of the things you want to make sure you don't do, once again, is make sure you don't do this negative distributed into here before you square first. Exponents come before what? Subtraction and multiplication. So we are going to square negative 8 first, which as we know is positive 64. So we're going to take the opposite of 64, which is negative 64. There's your answer. That's the value that applies for this one. It's not positive 64. We don't distribute that negative first, and we don't ignore this negative in any other sense. So this is negative 64. It is A. It's not positive 64. Number 29. Okay, the same idea. This time I'll be a lot quicker with it, plugging something in here. Substitute negative 3. Notice how I use the parentheses. Try and be the best you can with regard to how often negatives are used. There are a lot of them. In fact, there are no positives here whatsoever. Negative 3 quantity squared is positive 9. Notice how that squared negative 3, not squared the opposite of 3. Or squaring 3 and taking the opposite of it. Negative 4 times negative 3 is positive 12. So this becomes a plus. Or you should think of minus a negative. And then minus 2. 9 plus 12 is 21. 21 minus 2 is 19. That's it. Nothing else need to be said. When you solve an equation, you should know how to double check by substituting in as well. Number 30. Find the y-intercept of y equals x squared minus 7x plus 6. Great thing about this thing, if it's written in standard form, which I don't want you to trust that it's written in standard form, but when it's written in this form, when x equals 0, what happens? This term goes away. A times 0 squared is 0, plus b times 0. All that's left is c. When x equals 0, y equals c. So written in standard form here, if you're in this form, it looks like we are. When x equals 0, this term goes away, this term goes away, y equals 6. So x equals 0, y equals 6. That coordinate pair right here is 0, 6. The answer is C. Once again, 0 squared. The whole y-intercept thing is the value of y when x equals 0. We're substituting that. We're evaluating that. We're good. 0 minus 0 plus 6. Y equals 6. Awesome. And that's the actual coordinate point. I have 3 more problems for you. Which of the following 3 sides cannot form a right triangle? Okay, you might have already known from previous experience what a 3, 4, 5 triangle is, which means that can, which means this is not the answer. A 5, 12, 13 also can, so this is not the right answer either. 8, 50, 17 also can, that's not the right answer. These are Pythagorean triples, special ones that we've done before. The other one was 7, 24, 25. It looks like it's not on here. We're going to have to check some of the other ones and see how they are, see how they're doing. Now, if you wanted to check all these, what you'll do is create the 2 shorter sides as A and B and the longer side as C, and then you just see if it works. So we could have checked them here. I'm going to save you that time. Let's check C. Root 2 squared plus root 3 squared equals root 5 squared. Root 2 squared is 2. Root 3 squared is 3. Root 5 squared is 5. 2 plus 3 equals 5. You betcha. This one checks out as well. This can form a right triangle. So what you're checking for is if a squared plus b squared is not equal to c squared. That must mean it's the last one. Let's check and see if that's true. 1 squared plus 4 squared equals 17 squared. Yeah, right. 1 plus 16 equals 289. 17 equals 289. Close. Not really. Hang on, I shouldn't cross this out. This is actually the answer. Keep in mind, cannot. This one cannot form a right triangle. Furthermore, I'm going to be a little more specific. This can't form a triangle. if you think about it, it's not completely drawn to scale, but here's 17. Let's pretend like this is 1. Okay, and pretend like this is 4. Sure, I might be even pushing it a little bit. Who knows? How the heck am I going to make a triangle out of this? 4 can't reach 17. Even if I tried to bend it, it's just going to bend down like that. It can't even reach it. The only way for this to be possible, and I made mention of this before, is if a plus b is greater than c. If your two shorter sides are longer than your third side. 4 can't even be 16 and reach. If 4 is 16, whoops. If 4 is 16, it's probably going to go like that. It's going to go like, Can't reach. Obviously, you're saying, well, bend one lower. Yeah, bend it all the way down to the bottom right here. And this goes and flattens out as well right here. And guess what? It's the exact same length. You still can't make a triangle. The only way is if 1 and 16 together are greater than 17. Even if it's 16.1, at least that'll make me a triangle. This couldn't even make a triangle, much less a right triangle. So, you're good. Number 32. The simplest radical form of the square root of 28 over w to the 6th power is, boom. So, rewriting it. All right, I made mention of this with a product. If you take the square root of a fraction, that is also the fraction of two square roots, such as this and this. Okay? So it's equivalent to the square root of 28 over the square root of w to the 6th. The square root of 28, as I start to break that one apart, that's the square root. The largest perfect square, I believe, here is also 4. Square root of 4 times the square root of 7, so that equals 2 root 7. Square root of w to the 6th, once again, take out all your perfect squares you can. 3w squareds. That's w times w times w, so that's w cubed. So right now what we're looking at is 2 root 7 divided by w cubed. And I think that's as basic as I can make it. So it looks like it's going to be problem C, or part C right here. No offense, everything else is just wrong. There you have it. Nothing else I can really talk about with that. If, how about this? And I won't do it, but if there's a square root here, you want to rationalize this denominator, which means you want to multiply by the same thing on top and bottom here. So you get a rational number, not something with a radical there. Though I'm not going to do that, also because that wasn't the answer. Last one, number 33, factor completely. Okay. This is not a quadratic. In fact, it's a cubic. What I would make mention of to you every single time you do any sort of factoring whatsoever, besides you do your before you do your diamond and stuff. First of all, this is not set up for a diamond problem. This is a cubic, not a quadratic. But find common factors first. The reason that's going to help is because this is actually going to make it into a quadratic. X is a common factor of both terms. 5 is also a common factor of both terms. If you factor out 5 and x, you're left with x squared minus 4. Okay? So these are both the same thing. Now within here you have a quadratic. So you haven't factored completely. Notice how this is underlined? Notice how C, like, oh, look, C's my answer. Problem is, this is still factorable. So you're not done with this problem. We got to do some more. Let's factor x squared minus 4. In fact, I'm going to do it off to the side so you're not as distracted by the 5x. What you don't want to do is forget that this 5x still exists in the end of your problem. I'm going to rewrite x squared minus 4 and include the linear term, which is actually 0x. If you think about it, this is actually what it is. Right? So, let's see how this comes to be here. What two numbers multiply to negative 4 and add to 0? Well, negative 2, I was thinking about it, negative 2 and positive 2. These are additive inverses of each other, which means this splits up into 5x times x minus 2 times x plus 2. Okay, once again, that's what this splits up to, x minus 2 times x plus 2. So that's what we get there. Looks like it's a. As you can tell, these are just interchanged. Let's change this one into a plus, the other one into a minus. That'll be fine. But it looks like a would be your answer there. That's a complete factorization. The other one was not. Now, it didn't look like I did any factoring of any problems that had a non-1 factor, unless I did with the first problem. Let me take a look back at here and see if I did. This one did not either. All of them had 1 in it. So I don't know if it's worth doing another one for you. I'm not even certain regarding the final and such. Here, I will do one with you. I'll do, it's one extra problem here. Let's say we have 4x squared plus 11x minus 3. Okay? And you wanted to factor it in simplest radical form. Okay, first, like I said, find common factors. Looks like no numbers are common factors. Looks like no x's are common factors. Okay. So, found nothing. Now quadratic factorization. This is not as simple as saying what two numbers multiply to -3 and add to 11. For one reason, there is nothing. And for another reason, that's not quite how the factoring works. You have to think about what multiplies with what. You have to remember this -3, it is a product of two numbers, yes. But this number is a case of what these two numbers are plus whatever this number here is doing to assist it. So what I'm going to do is start with that generic rectangle. I'm going to get those terms, the quadratic and the constant, here and here. And I'm going to use the diamond with that. And the idea behind this is the product of these two numbers is equal to the product of these two numbers right here. So 4x squared times -3 is -12x squared. I'm more focused on just the number -12. I'm going to go ahead and write that. This is your product of your two values that you got to be looking for. They still add to 11. We're going to write that sum down there. So, two numbers here. Let's save you some time here. This is 12 minus 1 is 11. 12 times -1 is -12. So where do they go? Up here and down here. Doesn't matter in which order as long as they have the x attached to them, because that's truly what they are. 12x times -1x is -12x squared, much like this is right here. Now here comes the kind of fun stuff. We talked about how the x's belong here. Okay, but before, this was just 1x times 1x. Well, 1x times 1x is not 4x squared. 4x times 1x is 4x squared. But if I place this 4x right here, then that means 4x goes here. What does 4x multiply with to get -1? Apparently, it's -1/4. We're not factoring with fractions here. We're only factoring with integers. So apparently, I placed the 4 in the wrong spot. Furthermore, it might not even be a 4. What if it should be 2 and 2? Remember, 4 is not a prime number. It's a composite. 2 and 2 might work here. Like this, 2x times 6 gives you that. But the same problem exists here. What multiplies here? -1/2. We're not dealing with fractions in this case. That's something you can write it as, but it's not how we're going to be handling this. The last case scenario is let's place the 1 here and the 4 here. All right, 4x times, looks like 3. Looks like that fits. And 1x times -1. So it looks like this one works out. Right, this gives me all integers. This gives me this factorization. That's where you do some guessing and checking alongside this part right here. We do some real guess and checking to factor this thing out. Okay, so this becomes 4x minus 1 times 1x, which is just x, plus 3. And that's factored form. Now, I do not set this problem equal to 0. I was asked to factor it. I was not asked to solve for this. This is not set equal to anything. So don't go above and beyond this problem. I don't think you could or would, because it's a multiple choice thing. It's not like they're going to give you another, like this is A, and then B says x equals 1/4, x equals -3. That would be kind of funny if they did, though. But A would be the correct answer here, because this is just an expression. It's not an equation. Furthermore, once again, how can you do this with multiple choice? You can look at all 5 answers or whatever if you want and start distributing and figure out which one goes here. But I think the factoring is an important practice all the same. So there's an extra question number 34. This was a nice long little review here. But as always, I do hope this was helpful and that you can get something out of this. And if you have questions, please let me know. Fiend!